Dear student, today we are discussing JEE Mains 2026 Shift 1 paper. Okay, so the first question is of logic gates, certain logic gates, and we have to find what are the output of this logic gate, means what are the final logic gate at point C. So this question will be done by two methods. First is by truth table, and second method is by the we can say that analytical method, means we are finding by the help of the method of. Okay, suppose this a and a, the NOT gate will become a bar and b bar. Okay, the second method with the, and second is, this is a NOR gate. So the NOR gate output will be how much? A plus b bar का whole bar. Okay, and the output C will be how much? C will be getting where, that is a dot b ka bar. So okay, first of all I am solving with the truth table. So method one is the, suppose I am taking, this is a and b, so a and b, so I can say that a and b is the two input. So this is a bar and b bar, because NOT gate is like NOT gate will be there, and this is the NOR gate. So NOR gate output will be how much? The opposite of this part. So that is, this is the NOR gate, means a dash plus b dash ka whole bar. Okay, and the AND gate will be applied here, NOT gate will be applied here. So we can say that a dot b, this means it is no 0 1 0 0 1 0 1 0. Okay, and the combination of a plus b dot the a bar plus b bar whole bar, that is become how much? The 0 0 1 1 becomes 0, 0 1 becomes 0 0, and this is 1, and the inverse of this will be how much? This is a dot b, that become how much? 1 1 1 0, and this is nothing but the truth table of NAND. Okay, so NAND gate is the correct answer here. Now when we are going towards second question, in this second question they say that find the dimension formula of given the problem. So we are solving this problem. This question is solved with the principle of homogeneity equation. Okay, so we know about the principle of homogeneity equation, that if anything will be in addition or anything will be in subtraction, so they both having a same dimension formula. So according to this we can say that h dimension is equal to how much? B dimension into t, b dimension into t dimension. Okay, and L is equal to how much? L is given to us like here, L, because h is a height having length L, and b is any constant, and t is time here. Okay, so the dimension of b is equal to how much? That is L t power minus 1. This is the dimension of b. Okay, first part, this is the first part. Now second part, we are talking about dimension of a here. So when you are solving this part, dimension of a, then what is dimension of a here? Now here p is equal to, we can say that p is equal to a into b t square. Okay, so we can say that here p is pressure here, that is mentioned in the question, because rho gh is given to you. So there is p is pressure here. The pressure formula is force upon area, and that is equal to a upon b into t power 2. Okay, now so we know about that the pressure is equal to how much? The dimension formula of this will be m L minus 1 t power minus 2. Okay, and that's equal to a into, now b dimension we already know here, from here, that is L into t power minus 1 into t power 2. So we can say that the dimension of a will be how much? The dimension of a is, that is a is equal to how much? That is m L minus 1 t power minus 2 into L t power minus 1 into t power 2. So we can say that the a become how much? That is m into t power minus 1. So the a is equal to how much? M into t power minus 1, that is equal to, that is kg into kg per second. This is kg per second, second equation, and the first equation is, that is meter per second, second equation. So which of the following option is correct? So that is we can say that m power 1 t power minus 1. So the option number in this case will be the, which option is correct? That this option number first will be the correct option here. Why? Because a is m power 1 t power minus 1, and b is L power 1 t power minus 1. The both option, that option number first will be correct here. Okay. Now, according to question number 3, the alpha particle is projected from infinite towards the fixed gold foil of energy. That energy is given to you 7.7 mega electron volt. Find the minimum distance between alpha particle and the gold nucleus. Actually, this question is related to the alpha particle means the atom chapter with the Rutherford gold foil experiment. But we are also solving this question with the help of conservation of mechanical energy theorem. Okay, so whenever we are saying that that is k initial plus u initial is equal to k final plus u final, that is conservation of mechanical energy theorem. So the energy is given to you, this is the kinetic energy, that this is given to you. So according to this we can say that that is 7.7 mega electron volt. So mega is how much? That is 10 power 6 into 1 electron is 1.6 into 10 power minus ka 19 and plus 0. The initial potential energy is 0. The final kinetic energy is 0 and the initial, this will be how much? 9 into 10 power 9, that is k q1 q2 by r into 2, 9 to 10 power 9 into 2 into 1.6 into 10 power minus 19 into 79. That is a gold, the value is given to you, z value is given to you. Okay, into how much? That is 1.6 into 10 power minus 19 divided upon r. So we have to find the r value here. So after solving this part, we are getting here, that is 7.7 into 10 power 6 into 1.6 into 10 power minus ka 19, and this value become how much? 9 into 10 power 9 into 2 into 1.6 into 10 power minus 19 into 79, 1.6 into 10 power minus 19 divide upon r. So r will become how much? After cancelling each and every term, we can say that 9 into 10 power 9 into 2 into 1.6 into 10 power minus 19 into 79 and divide by that is 7.7 into 10 power minus ka, that is plus ka 6. So whenever we solve this, we are getting this, that is 295.5 into 10 power minus ka 16, and this will become 0.2955 into 10 power minus ka 13. So the final value become how much? 0.3 into 10 power minus ka 13 meter. This is the value. So the option number third, we can say the second, we can say that second option is the correct one. Okay, now we are moving towards the question number 4. The question number 4 says that from the ring of area, this the resistance is that 100 ohm and the magnetic field B is sine 100 T Tesla. Okay, but this B is given to us, area is given to us, and R is given to us, passing through the perpendicular ring. Okay, find the heat produced in the time period of, okay, in one time period of two. Okay, so we have to find here heat. Now we know that phi become how much? That is NBA. NBA, we can say that 1 is the area. Okay, B is 1 into area is 1, area is 1 NBA. Okay, and we are taking that approximately minimum 1 turn will be there, n is equal to 1, and area become how much? That is sine into 100 T. Okay, so the phi will become how much? Sine 100 T. Okay, now what is EMF is equal to minus d phi by dt. So once we differentiate this function, then this become how much? Minus of that is sine, that is d into sine 100 T divided by dt. Sine 100 T divided dt. 100 T divided upon dt. So when we differentiate this function, we can say that this is 100 minus 100 cos 100 T. Okay, so E value become how much? Minus 100 cos 100 T volt. This is the E. Now current is equal to how much? We can say that E by R. V is equal to IR. Formula we know that V is equal to IR. So current is equal to E by R or V by R. So that is how much? Minus 100 cos 100 T divided upon 100. That is equal to minus cos 100 T. So this is the current we are getting from here. Now the next point, we can say that here, the heat formula, IH is equal to how much? The heat will come how much? Heat is equal to I square R into T. So once I am solving this question, I square R into T heat formula, then what are the value here? I am solving here. That is heat is equal to I square R into T. So the current we are getting from here this much. So again, I'm finding for the time period is given to you for T is equal to 1 second. I think so, है ना? Time is given to you. So find the heat for one time. So one time period time is given to you for one time period. So we can say that H is equal to how much? The heat is equal to I square R into dt. Okay, limit from 0 to t. The time period will be given to us 0 to t. So I can put the value here, that is cos square 100t into 100 dt. So after solving this, we can say that 100 is the constant part, so we are taken outside, and a cos square 100t into dt. Now after integration we are saying that for one time period, the cos square 100t, the average value become how much? Approximately half. So the t is equal to how much? This value become 100 into t by 2, that is equal to 50t. And we know that t formula is 2 pi by omega. Okay, so we can say that this is 50 into 2 pi by omega. So while solving this formula, omega, already we know about that omega is equal to how much? 100 pi. So we can say that sin omega t, so omega is equal to 100, already we know about that. So we can say that this is how much? 50 into 2 pi divided by 100. From the equation, though this is 100 cancel out, so the value become how much? Pi only. So pi is the correct answer here. So we can say that according to given data, which of the following option is correct? That is pi. Means the question number 3, the pi is the correct answer, means 4 option is the correct one. Okay, so from here we can say that pi is the correct option. This question is asked from, this is 10 power 10 minus 10. Okay, this is a chapter number 2 question. V1, that is V1 is given to you, that is K Q1 by, that is R1. Okay, or RA, we can say that KQA by RA. VA is equal to KQA by RA. So the QA is equal to how much given to you? That is how much? The value of this Q is given to us, that is 9 into 10 power 9 into how much? That is 10 power minus of 10. Q is given to us, and the value R is given to us, that is how much? That is 4 minus 0 ka square plus 4 minus 0 ka square plus 2 minus 0 ka square and under root of this function. Okay, this is the value. Now after solving this VA, the VA we are getting that 9 into 10 power minus 1, and this is divided upon how much? This is 16 and that is 4. So 16 4 is how much? 32 4, 32 plus 4 is 36 square root, that is 6. So 9 into 10 power minus 1 by 6. So we can say that 3 by 2 into 10 power minus 1 volt. This is the first part. Now when we are talking about second part means VB. The VB again same. So VB is equal to how much again? That is KQ by RB. Okay, KQB by RB. KQB, that is the value of this is how much? Same. Okay, that is 9 into 10 power 9 into 10 power minus of 10 divided upon, that is 3, well the same formula. So we can say that 3 into 10 power minus 1 volt. Okay, now we are saying that the work done is equal to how much? That is Q2, that is given the question, that is VB minus VA, and that value become 2 into 10 power minus 6 into 3 minus 1.5 into 10 power minus ka 1. So the final value become 3 into 10 power minus ka 7 joule. So this is the answer. So we can say that 3 into 10 power minus ka 7 joule. This is option number first. Now again we are solving about this question number 6. That question is of electromagnetic wave, EM waves question. So in this question we are trying to solve the question by the help of the given data. Okay, so in this question they say that the electromagnetic wave. So this question will be x, say that Ez is equal to how much, that is 63 sine omega t minus k into x. Okay, this is the question. So we can say that the electric field is along z axis, that is k cap. Okay, so c is along I axis. Okay, and c into E, this is along how much, that is b cap, and b is along the j axis, that is negative j axis. The option of this number 1 will be the, I think, correct answer here. So according to this question we are saying that the b that is the b naught is equal to how much, that is E naught by c, and we consider 63 upon 3 into 10 power 8, that is 2.1 into 10 power minus of 7. So we can say that b of y is equal to how much, minus 2.1 into 10 power minus 7. Okay, sine omega t minus k into x. Okay, so this is the question, and the option number 1 is the correct one. Although while finding the value of component of that j cap, it is a negative, we can also say that this is the option number b1 is the correct one. Okay, now